In my streams, I like to wander from open source repo to open source repo, and because of that, I like to use Docker development environments. Most of the environments I've worked with have had quirks, and at first I thought this was due to the charm of the repository. It was about 5 hours into a stream with Nikki T online from 4M and Black Glasses from the Alt-F4 stream. We were trying to fix Dev2's Docker setup, and that's when I learned Docker isn't magic. That's a direct quote from Black Glasses, by the way. Docker isn't magic. There is no perfect push button dev setup. And there's a couple of reasons why. A big one is that Docker doesn't know what's in your containers. Docker knows whether the process that you've started is running, stopped, or failed, but it doesn't know if it's supposed to run. It doesn't know if it has a startup period and then a running period, or if it's supposed to complete successfully and queue the next thing that happens. Another big thing that results in these quirks is the fact that Docker containers are tested regularly, but Docker images are not. In Docker, the very first time you call Docker compose up, what it does is it takes all your base images and it creates them, and then it caches those images. And every subsequent time you call Docker compose up, it uses those images to build containers. The big difference here is images are like a snapshot of an OS at a particular moment in time, and containers are environments where you can run things. So your containers are built off of cached images, which means even if you change some of your install instructions, even if you change how you're structuring things, those environments are not being updated, which means even if you use Docker dev environments day in and day out, sometimes your Docker setup can still fall out of date. Now that we've talked a little bit about some of the downsides and we've started off by saying we can't have a perfect dev setup, that begs the question why we should still use Docker. The really big reason, in my opinion, is that our applications right now are a giant pile of dependencies. Every single dependency in your application has its own install guide and has its own troubleshooting guide. And that troubleshooting guide is the really big part here. If you aren't using Docker, you have pretty much two other options. We're going to throw Vagrant out the window for now. The two real options that you have are a list of commands that somebody is supposed to independently run, or a script that runs those commands for you. Either way, you can run into issues with other dependencies that are installed, your operating system, or other incompatibilities. And again, we have the same problem with setup scripts where when you run a setup script a second time, you're not running it on the same environment you ran it on the first time. So there's issues there too. My big issue that I have though is in the place of setup scripts, most of the time people just have install guides where they literally tell you to follow all of these series of steps. And in any case where you've got a series of steps, I find you've also got one of these. You've got a DevOps engineer who is responsible for guiding each new hire through the development environment creation process. Most of the time I see this in enterprise systems, but you can also see it in open source ones. Although more often in open source, if they can't set up the dev environment, they're just gone, like you've just lost them. So what this really is about is even if you document those changes, even if you have somebody who has that knowledge, they are wasting their time guiding people through the dev environment setup process rather than having a recreatable process that works multiple times. Another real advantage to Docker is having disposable environments. So if I'm dealing with some quirkiness in my own environment, I can discard the whole thing. Just wholesale, get rid of it. And another good reason to have disposable environments is the one I mentioned at the beginning. I like to wander from open source repo to open source repo. And because of that, if I were to install everything locally, I would have the versions of Ruby between 2.7.0 to 2.7.2, and I would have 3.0.0. And I would have two versions of Python despite being a Rubyist, to say nothing of the number of versions of Postgres I would have and the potential environment setups that could result from that. Being able to discard several gigabytes of like environment when you're done working on a repository is really beneficial for people like me who like to do drive-by PRs. And if your open source repository is set up in this way, then it encourages folks to do drive-by PRs. All right, now let's talk about Dockerizing your application. There's two main ways, and then we're going to get into some open source examples that you can reference on your own time. So the first main way of doing it is just the services. In this one, your main app is still on your computer, but the services that support it are containerized. So things like Postgres and Redis and the like. Some of the benefits to this, most of these technology providers, they have images already, like Postgres, Redis, Elasticsearch, they all have them. Also, these services tend to be the more difficult parts of setup, so you're not installing C libraries anymore, no PostgreSQL, nothing like that. So it's a lot more straightforward. The other advantage is that a Docker Compose file that is made up of just the services is mostly composing existing images, so this is one of the easiest Docker setups to create. Some of the downsides here, you're still manually managing all the app dependencies, so I said no installing C libraries, but you're still installing ImageMagick. Also, you need a setup guide. So we go back to that DevOps engineer from before who's spending an hour with everybody trying to get their stuff set up. Also, every time you want to start up the server, you need to run at least 2 commands. Your first one to start your ancillary services and your second one to start your main app. The other thing is you've lost cross-platform support. I put Windows support here because I'm a Rails person, but you can also think about this in terms of like you haven't managed to isolate any configuration issues that could arise from being on Mac OS or Windows or any other platform. Now let's talk about the other main way of handling Dockerizing your application, and that's Dockerizing the main app too. So this is the all containerized approach. With this one, VS Code extensions normally don't work unless you're opening it up inside of the container, or if you've got some special configuration here, you have slower startup speed and all of your commands are longer. So you're doing Docker, Compose, exec, web or Rails, whatever your container is, bundle, exec, rake, whatever your command is. And that's significantly longer, and a lot of people try to shorten this, which we're going to come back to later. Now, some of the benefits of this, you have a reliable, consistent setup, you have Windows, Linux, and Mac support, and you have an easy and complete teardown of the application. Those are going to be the pros for pretty much every example that we look at after this, so just kind of keep that in mind, because I'm mostly going to focus on the areas where things went wonky. Speaking of which, it's time for our first real-life example. So this one starts at a Ruby 2.7.3 Alpine image. You remember images from before? It's got 4 services, Web, DB, Webpacker, and Chrome. Chrome is Selenium Chrome. That one's used for testing. This is actually a really big benefit because what you can do is you can have a separate image, you can have a separate container for managing Selenium Chrome. And then you don't have to worry about whether your local version of Chrome is incompatible with your Chrome drivers in your feature tests. Webpacker here is Webpack Dev Server, DB is Postgres, and then Web coming back to that is my Rails instance. This one has a multi-stage build in the Docker file. Multi-stage builds allow you to put checkpoints in and store basically the status of the image at that point and then continue onwards. So the Web and Webpacker are built from one of those checkpoints called Rails Builder. Node modules are stored locally. This is going to be true for the rest of them, but for this one, I think it's potentially important. So the quirk here is we have multiple build commands. The first command that I run just builds images. Then I'm initializing the database, and last but not least, I'm installing my node modules using Yarn. Now we get to the quirkiest part of this. I find myself rerunning node modules about once a week. And here's the weird part about that. I'm not doing anything interesting with Yarn or Node. And to be honest, I haven't kept up with my security like dependencies and stuff like that. So I have no idea why I'm needing to do this every week. It's very strange. The other quirk is that the testing container is always up and waiting, regardless of whether I have any intention of running my feature tests or not. Let's talk about number 2. This one is really similar to the last one because both of them were created by the gentleman in the corner, Exegete. Exegete helped me significantly with the Docker setup for number 2 for Hunters Keepers, so number 2 is very similar. So I'm only going to focus on the differences here. Here we have a Ruby 2.7 Alpine image as the base, and then the services are Postgres, Redis, and Web, where Redis is an in-memory database, and Web is our Rails version. This one has something interesting. So the Docker ignore is populated using the git ignore, and the quirk here is that the server pit doesn't disappear, so if my computer just kind of like shuts off, then it keeps that server pin. I have to open up the repository manually and delete it, unless I like remember to close out of the container properly before I exit. Anyway, that's the quirk with this one. The next one is Casa. So this one's Ruby 2.7.2 Alpine. Services are Web, Postgres, and Selenium Chrome. Selenium Chrome, we're seeing that feature test come back. This one's kind of interesting because it has an entry point that removes a running server PID and prepends bundle exec to all the commands. I thought this one might cause issues with bundle exec, but it actually was just fine. They also did something strange, which was they created a Docker script folder that calls Docker commands for you. These normally look like Docker /test, things like that. None of these work in Windows. The other downside here is that you're memorizing a new set of non-standard commands, which means that you're not learning Docker, you're not learning Rails, you're just learning something that only applies to this repository. From 4M, this is our first time looking at a custom image. So this one's at quay.io 4m/ruby272. You can do some interesting things with custom images, like go ahead and run all your dependencies and store them in the image. That way, when you pull it down, you're already starting with the mostly pre-configured container. The services here are significantly more extensive, and the reason for that is 4M is the repository behind popular sites such as Dev2, Code Newbies, and therellikins.com. I wanted to point out something in particular about these varied services, and one of them has a network URL or a network host name. And basically what that means is instead of being found at localhost 3000, inside of the Docker network, you can basically access this particular service at Rails 3000, right? And that URL is used by both Seed and Sidekick. We're going to come back to that later. So something interesting about this one is they use Dockerize to build in delays. I think it's about 45 seconds if I remember correctly. That's an interesting choice, and it's one way to get around the kind of like orchestration problem, but obviously it's not perfect. They also have an entry point that removes existing server PIDs. And do you remember how last time I talked about, like, if you're creating these custom commands to call Docker commands, then you're not learning things that apply to other repositories? Here's an almost immediate example of that, because in this one what they do is they alias commands like precompile inside of that Docker entry point. So we've got a completely different interface to those commands from 4M's repository. Let's talk about the quirks with this one, and by quirks I mean open issues. This is the only one of our Docker setups so far that has actual open issues against it. The first one is that you cannot connect to the test database. The next 4 are all related to the network host name that I mentioned before. So OAuth points to the network URL. What this means is that when it's generating its redirect URL, it's saying, my name is Rails, so the redirect is Rails, right? And then I send that message outside of the Docker network to the OAuth provider, which in this case is GitHub or Twitter. And they're looking for a localhost URL for the redirect, and I'm passing them a Rails URL. That's what causes this invalid auth token due to mismatched Rails localhost URLs. If I attempt to change my OAuth provider, that's the GitHub or Twitter, so that it references that Rails URL that's coming from the code base, then it's going to try and redirect to Rails, and Rails doesn't exist because we're outside of the Docker network. So that's the problem with that one. There's also a CORS complaint in Webpacker not working. Both of these also seem like they're related to the fact that the application thinks its name is Rails and everybody else thinks it's localhost. Cool. So that's a summary of like 4 examples of open source Docker setups that are out there. You can click any of them. The slides are available online. So here's a summary of kind of the learnings that we should have taken from that. Entry point should remove the temp server PID. Adding it to your Docker ignore can cause issues on restart. It's good to use default images like Redis, Postgres, etc. because you're able to make quick wins. Don't rely on network host names like HTTP Rails because it will get confused about what its name is. And also don't build an interface layer over Docker. If you have a problem with how long Docker commands are, you can use aliases locally, and then those are going to apply to any Dockerized application you go to. If you build a custom Docker interface, it means you're not documenting your true interface in the case of Casa, or you've got undocumented commands that nobody knows exists until they decide to do a presentation on your Docker setup. Thank you all very much for watching. I hope you Dockerize your applications so I can come visit them. Bye!